Hi there. Today we're going to be having a look at the July practical test from 2020. If you have a look at the website, you'll find the questions are online, and as you scroll down towards the bottom of the screen, you'll find the data files. Please extract these in an appropriate folder, as I have done here. We'll be working with these. On the screen now you can see that there is Super Online, the project file, Online Supermarket, a database file that will be used in the exercises, Form Main, where you'll be doing most of your programming, and UDM, the data module, which contains the data controls that will enable you to work with the database. Right, please open Super Online. In Delphi, you'll find on your screen Form Main, which, if you have a look at the design, it has several buttons we'll use for the questions. We're going to start with List Kimberly. And if you look at the questions on the list of orders that come from franchise distribution manager, so needs to arrange delivery services for the orders. These first questions use Delphi's direct database access. We're going to be working directly with the tables, and for this we're going to use a filter. So remember, the database controls are on the data module, and we're going to be using table orders. Table orders, if you have a look at the question paper, is the one that includes the city information. So table orders dot filtered equals false, dm dot table orders dot filter. We're going to set up the filter we need, and the filter is quite literally that the city field must be equal to KBY. Now remember that this is a string, and we're going to have to tell Delphi that this is. Now remember that this is a string, so we'll have to signal to access that this is a string, which means we're going to do this in a quoted string. And there we are. Last bit. Table orders. Don't forget to say which table this is. There we go. Table orders is filtered is true. And we can check that quickly. There we go. Just the ones from Kimberly. Right, question 2. Wolfie Batson forgot to include coffee in his order, order number 5. Add a new item to the purchases table to reflect this order. So we're going to be working with table purchases, dm.table purchases. There we go. And we need to insert a new record. Now this inserts a new record. It also signals the database that this is in edit mode, so we can insert the data. dm.table purchases, and we're going to add the ID, colon equals 1001. Let's just cheat a little bit to speed up some time. And order, colon equals 5. And product is coffee. Quantity. Note, even though the question says quantity, the table field's name is QTY. Colon equals 1. And last cost is 65. There we go. All right, at the moment it's now built this insert operation in memory in Delphi. We still have to commit these changes to the database, so we're going to have to post this, which will then send this to the database. So we can save and run. We'll only be able to do this once, so just check. There we go. Last order is 500. Field ID can't be modified. That means I made a bit of a mistake in the question paper. This, you can see there, the ID field is a unique identifier, and if I have a look at the database itself, I'll have to also stop the program for a moment. Okay, let's have a look here. Purchases. I want to have a look at the design view. You'll see that ID number is set to an auto number field. So if it was just a regular number field, then the insertion instruction would have been fine. Auto number means that Access is going to choose an ID number itself. So I've commented out that particular line. We can execute this now, add item, and you'll see the new item has been added down at the bottom, in this instance number 502. Alright, last part of question 1. Elston Keegan has called to say she mistakenly added house help cleaner twice in her order and wants to delete one of the items. Delete the product with ID 395 from order number 7. So we're going to have to find product number 395. There are two ways of doing this. The first way is to use a filter to find that particular product and then delete it. I'll demonstrate that one quickly. And because it uses a filter, we can copy this code. We're just going to have to change it from table orders to table purchases. There we go. And I'm going to filter where ID, as you can see there, it's the ID field. And we're not going to use a quoted string because it is just a number field, 95. There we go. And having found that particular field, I can then say dm.purchases.delete to delete the current record. There is, that's table purchases. We will now be sitting in that particular record. It'll be the only record that is showing in the table once the filter is applied. So the delete operation will apply to that particular record. The other way of doing this doesn't use a filter. Instead, we can say dm.tbl_purchases.first to move to the first item in the table, while dm.table_purchases, and we're looking at the ID field again, is different to 395. Do, just in case this has already been deleted, it's always a good policy when you're using search routines, always check to make sure you're not going past the end of your data set. And that should be not. There we go. What happened to the do? I seem to have deleted the do. Okay. Just so you can see the whole, I'm taking out these two panes on the right. dm.table_purchases.next. And that will carry on until either we find the item we're looking for or until we run out of items in the table. So let's just check and make sure that we have found the item. If then I'm not going to do anything if I haven't found the item. We assume that we have now found it. The row pointer for the table is in the row which contains that particular item, and it will delete it. So let's see. Delete. Well, see if we can find item number 395 for us, just so you can see it go. There it is. Delete. And 394, 396, it's gone. Right. Question 2. The second half of this paper uses SQL, and the branch manager in Bloemfontein wants to send out an SMS advert to all the subscribers in his city. Create a query to list all the clients in Bloemfontein. This will be a basic select statement. So select everything from, and just this is the orders table, which includes the city information. We're going to list everyone from Bloemfontein. So from orders, because we want the city Bloemfontein, there's a where clause, city equals it says show only the customer name and phone number, so I can't use select everything. We're going to select customer and phone. Those are the fields that must show. So customer, comma, phone. We aren't asked to order this in any particular way, so this is where the question requirements stop. If we were, then I would order by customer or something along those lines as the last line, but we'll stop there. All right, let's apply this to our SQL. So dm.query, query shopping, .sql.text colon equals, there are 3 lines, so I'm just going to make some space to put 3 lines worth of SQL in, and we can drag this into place. There we go. Right, let's see if this works, although it won't right now because I've forgotten 2 things. Bloemfontein there, you see, has to be a string in SQL. In other words, Microsoft Access has to be able to interpret it as a string. So I'm going to have to tell it that this is a quoted string to ensure that quotes are correctly placed around that word. Then dm dot query shopping dot active is true. Just for safety's sake, it's also a good idea before we start to set active to false. Right, let's see, save, run, and list. Save your work regularly when working in Delphi. All too often, Delphi crashes or something else goes wrong, and there's no real autosave. So if you've worked for 3 hours on your assignment and you intend to save just before you hand in and Delphi crashes, you lose that 3 hours worth of work. Save often. Let's have a look at question 2.2. The franchise want to give an incentive to staff of the branch with the highest number of individual items sold. Create a query that determines the number of items sold in each city and use the quantity field to determine this. So we're not interested in the value, we're just interested in quantity. And second, you'll notice we have to use city and we have to use quantity. This is a field in the orders table and a field in the purchases table. And as soon as we've got fields in two different tables, that means we're going to have an inner join to connect these two tables. And the way we're going to connect them is to make the join on the primary key foreign key relationship. In other words, where the orders field from the orders table is used in the purchases table. Right. Our SQL then will look something like this. We need to select city and quantity. So select city, comma, QTY, but we're not interested in just quantity. This will show Bloemfontein 5, Bloemfontein 3, for every purchase in Bloemfontein. I rather need an aggregate of this. I want to know how many were done in Bloemfontein. So I'm going to have to count. I'm going to have to add all the quantities together. Remember, in some cases, more than one item was sold at a time. As we're not given a particular field name to use, so let's call this total. From, and this is going to be, here we have to establish our join. So orders, inner join, purchases, on which field has that primary key foreign key relationship. Orders dot, if we look at the table, orders dot order. Equals, and it's purchases dot order. Purchases dot order. Now we have an aggregate function, and as soon as we have an aggregate function, any field that is not part of the aggregate function has to be part of a group by. So we're going to have to group it by city. This makes sense. In any case, I want to know how many orders, what was the sum of quantity for each city. So there we go. Right, let's put the Delphi wrapper around this now. dm.qry shopping .active equals false. Let's turn him off. dm.qry shopping SQL.text equals, and we're going to have 4 lines of SQL this time. So I'm going to make some space for 4 lines. And then we can drag and drop this into place as before. There we go. And when done, dm.queryShopping.active that should be it. So save the work and let's see. Items by city. There we go. Bloemfontein 63, Cape Town 112, and so on. Right. Question 3. We're going to try and print out a shopping list that needs to be printed for each client. That must also include the total cost of each item. Costs in the purchases table are indicated as a price per item. Use an input box to obtain an order number and create a query to determine the actual cost for the items. Use a calculated field named item value that determines the actual cost of an item by multiplying QTY by cost. So we're going to make a new field, and it's going to be the total that you arrive at by multiplying quantity by cost. As usual, let's have a look at our SQL. We're going to select. We want to show the item. We're going to show the product, and we're going to show the cost as indicated in the little table example. Okay, so select product, and then we're going to have QTY multiplied by cost as, this is where we give our calculated field its new name, item value, from purchases. And we need to narrow this down, so we're only showing for one particular order. Where order equals some other value we're going to be getting from an input box. So let's create that little variable I've just made. You can call it anything you like, but I named it S order number, and it's going to be a string because that is the result that will be returned by my input box. S order number is an input box. Input boxes, remember, have three parameters. We have the caption, you can choose a message to prompt people what to type. And now we have to add the Delphi wrapper around this SQL. Also remember that this particular item is not going to appear literally as it does over here. It is a value that comes from Delphi. So the SQL string will end. We will add that value, which already is a string. It's a numerical value, so I don't have to put it in inverted commas. I don't have to use the quoted string function to do that. We'll use it as it stands. Right. dm.query.active dm.query.sql.text. There are 3 lines. Let's make some space. And we can take these lines and put them here. SQL statements, remember, end with a semicolon. And this will add literally the number that is displayed in the input box, entered there, in the where clause, where order equals the number that got typed. Right, last, we have to make this active. Query shopping.active equals true. Save again, and let's see what happens. And we generate the list. Choose number 2. We have an error, syntax error in where clause. Sometimes these are a little bit hard to track down. And there's no obvious error that I can see here. So to demonstrate debugging of this, I'm to put a break on just before it makes this active and run this again. Generate list. Let's have a look at what the actual SQL is that has been generated. And you'll see select product, QTY from, okay, I noticed a spelling mistake in item value, but that doesn't affect the way it runs, from purchases where order equals 2. Nothing is obviously at fault. Something it could be though is, remember the way SQL works, the select statement has select from where order by. It's possible that Access is interpreting this as part of that instruction order by. I can get around that by instructing it to interpret this explicitly as a column. Let's see if that's going to work. And generate list 2. This time it works. Okay, so I wasn't expecting that, but in this particular instance I've got to make sure that Access interprets the word order here as the name of the column. And the one way to do that is to use square brackets around the border. I would have had to do the same if the column name had a space in it. The other way I could have done it is to prefix this with the table name, which tells Access this is the column purchases.order, the full name of the column. That will also work. And generate list just to test. There we go. Right. Remember, in a test situation, if you're reasonably certain that your code is correct, don't waste time on trying to find places that might be causing a problem like that. In that case, that was my error in not double checking that particular option when I set the test. Someone who had left that out and left this like that would have got the marks anyway. So question 3, which also has 3 parts. We're going to write data to the file order.txt. So we need to do the basic admin you need to be able to write files. Let's create a connector, a file variable, which I'm going to call con. And we're going to have to write lines to the file, so let me create a variable to hold a line of text. Right, let's see what we can do. We're writing the file, so we don't have to check to see whether the file exists already. We're going to create it. I can begin with a sign file, con, and that is order.txt. Rewrite con, and we're going to finish off with close file con. All our writing to the file is going to happen in between that rewrite and the close file. Now, this question involves a few small extra details. Notice it should include the delivery details as well as the order details as shown in the example. So we're going to have to use values from the first table, table orders, as well as from table purchases. Or to be precise, seeing as this is the data that was generated at the bottom of question 2.3, we're going to be referring to the query from 2.3 for these values. And we'll use a filter to narrow our options down to the appropriate order number. So dm.tableorders.filtered equals false. dm.tableorders.filter, we're going to have to construct our filter, and we're going to be looking for one where the ID is equal to a value, or rather the order is equal to a value. Order, because that table, as you will recall, has an order field. And now we have an issue. How do I know what order number? The question implies that you use the same query that was used in question 2.3. I could, of course, rewrite the SQL, but that seems a bit of a waste. The S order number variable is also not accessible to me because that is a local variable in question 2.3's procedure. I don't want to have a second input box. Then there's a chance that the input box for the delivery address will end up being different to the results of that query. And I don't want to duplicate the SQL. So I'm going to instead make this variable a global variable, which means that that value will be accessible in both routines. So order equals plus S input. S order number. Then dm dot table orders dot filtered equals true. So in the table orders, now the only lines that would be showing, the only record that would be showing, would be the data that I need to be able to show on the top of the label. And we can write that information to the file so long. I can say write line order number S order number is already a string, so that's fine. Remember, this is being written to that file con write line con customer. This will come from table orders. The customer field. And then we have address. dm.table orders city Now, this isn't an absolute requirement, but let's add the decorations. Right. Now, I'm going to have to be able to add all the items from the query. We're going to have to go through that query and add each item in turn. So let's start with dm.queryOrders.first, then while dm not dm.queryShopping.erf. We're going to carry on for the full range of all the items mentioned in the orders table. Begin. And we can build our line, write line, con, and that will be the product, which is dm.orders now, query shopping, product. Remember, the query has the query We can add a tab. It doesn't tell us how we're supposed to space it. We've got a little table which outlines it, but honestly, tabs will be fine. And our query returned a item value. I'm going to fix up the spelling here because it's going to mess me around. So dm.query shopping item value. And then we're going to go on to the next item. So dm.queryShopping.next. All right, that gives us the output we want, with the exception of the total. I must still add those values together. So we'll need, I'm not using this little line, just writing the strings directly. Let's change that to a iTotal, or remember this is a currency format, so let's call it CTotal, currency. There we go. And start off. It's always a good idea to initialize your variables. Then you know where you stand. And we're going to add, for each one, CTotal equals CTotal plus value. And Delphi should automatically convert that to a string when used in a string context, and convert it to a currency format when used in a mathematical context. If it doesn't, then we'll have to use currency to string in the right. Right, let's save this and try it out. Now we're going to have to generate the list, order number 2, OK, save the list. Could not convert variant of type string to currency. That means that it didn't do the conversion. So QSTR, there we go. Let's try it now. Generate list 2. That didn't generate an error, but it does strike me that the one thing I've forgotten to do is, while I've now added the total together, I forgot to write that to the file. That was the last line that we had to add. Add some decoration, and let's write total plus #9 plus CTotal. Okay. Final test. Generate a list. For number 2 again. Save the list. Let's see what happened. There's our order, and there's our file. The customer information, the items, and the total. And that's it. I'll see you again next time. Bye for now.